Hi guys, welcome to my YouTube channel .NET Gyan. Today I am going to show you how to build an agent in a Python application using Google Generative AI package and Gemini model application. So let's start. So this is the application which I have created and I am going to demonstrate this one. And in this there is a prerequisite you need to install Google Generative AI and python.env to run the application. Of course, the Python should be installed in your system. So let's go to main.py. In main.py, I have imported several libraries, Google Generative AI libraries, and or agentic files, which will be act as an agent. And I also show you uh, what is written inside this agent files. So our two agents I have used. One is it will book a train ticket, and one shopping agent which will place a order after confirming from the user. So these two agents will be will be used in this application. So let's move to the agents. So in shopping agents, I have created one function, confirm shopping order, where once user adds product quantity and address in the chat, it will confirm. It will ideally it should call the API, which will be custom logic. It can be implemented, but for now I just used the hard-coded product listing so that I can demonstrate the functionality in this demo. And after taking these three element, I have attached this product information. This is a demo product information, and what user asked, quantity, address, and product. And this will return this prompt, and this prompt will be used by the model to identify a suitable product for the user. Another function I have used after confirmation, if user says we can go with the order after selecting a product, then he can the LLM will come to this function and it will place order. Ideally, it will call the API to place order, but for now, I have just added the user selected product and its listing, and it will then confirm that this order is placed once user confirms the product. Another is train ticket agent, where it will take details from the user from location to location, date and passenger names. Okay, and this information will be sent to the LLM. If any location is information is missing, LLM will ask to the user to give proactively ask to the user give this information to proceed further. So these two agents I have used. Let's see how I have utilized these agents, how I configured these agents into the code in a main.py. So first of all, I have to load the environment, and then I have already added Gemini key API key inside the env file. That key will be used to configure the Google GNA generative AI object package, and I'll just configure this key, and thereafter I have added the tools. These tools, the schema is written inside the agent. I'll show you that. So these are function, but we need to give a schema which function does what and what are all the parameters, input parameters required by them. to function the agentic flow. So this schema information to be given to the models. Similarly, shopping order schema, then place order schema. Uh, these are the parameters it requires. So these things uh, we need to provide to uh, LLM to register the tools so that it will identify the tools when user asks the question, and based on the identification it will provide us tool information, and based on tool information we will call the tools, and it will give us the activity which user wants. So we need to create a tools array, and the tools we need to provide to GenAI.generative model, which will provide as a object of basically it will return the GenAI object, and this object this method requires model name, which model names to be used. In this case I am using Gemini 2.5 Flash, then tools which we have register here, and then system prompt. The system prompt is important because it will based on system prompt it behave behave that way. In this system I have already given intelligent access to can help users to various tasks such as booking tickets, confirming shopping orders, then place the shopping order, call appropriate tools as per provided tools metadata in proper order to smooth agent workflow. So this system prompt, once you give, it will behave the way we have instructed in the system prompt. We can give more detail in system prompt also. If the agentic flow is complex one, then you have to provide a proper instruction to act. In this case, this is not that much complex agentic flow. So this system prompt is working fine for the case. Okay, so once the we get the generative model objective here, we use this object to call the LLM. So for that I have taken user input, then check that if it user entered exit, then it will close this application. I have added this contents. It is actually context array. So I am using 10 context means user and agent flow. So it will keep the 10 previous history, and remove all means recent 10 it will store, and remove all prior to that. So this is the code for that. If user is asked first time, it will add the initialize the contents, else it will append. It will if it user is adding question, follow-up question, or adding one by one question, then it will append to that array. And then I call the call model. This in call model I have written the all logic to uh, for the agentic flow. So it will call the generate content method of GenAI model, and I am providing the that context means whatever user has input given, and also the previous context, whatever conversation happened with the model will be passed to this generate content, and this will again hit the model, and model result will come to this result object, and then basically we read that data, and we append the output content into the into the that context. Thereafter we check whether any function call is required. If it LLM says that the function call is required, then it will check the function name and arguments, and whatever tools we have registered, we means we iterate to that tools, and that every tools function declaration we check that its name is equal to function name. Function name is coming from the LLM. If function name is identified by LLM, then it will check is it available in our metadata declaration, which is we have given in the models tools. This is we have given past here. We have registered these tools. This tool object will be will return here in this model.tool tools, and from that tool the function declaration, and then we check one by one function with given models, whichever model return the function name, which is model have selected this function should be called. If it is matching, then we go to there, and then what we do, we check whatever function we have written, we check those functions and call the respective functions. Providing the function argument, it will dynamically assign all the values to the function variables. So it will automatically assign appropriate function parameters value, and then this result will be stored in result, and then we again store this function result object into the user input context to store the history, whatever conversation happened with the uh, model. So it is model response, role is model, and parts is tool, function name. We have given function, and whatever function result is returned by the function, we will append to the context. Okay, so once this happens, then we again call model. So we have again hit the same model. We have written a recursive function call model, and once the result is sent to the basically, if it is a function call, then it will again call the model, and again it will do the same thing. If no function call required and LLM has given the output directly output, it will not come again here. It will exit and it will return the output string. Here we have written the actual final LLM output, and it will print that output to the screen. So in this function, we have just read the what information written by the LLM. The part dot text, it will appear in this uh, text attribute. So, and also we have again stored in the context history, so that in subsequent user interaction, this will remain in the context, so that we will have that history with us whenever the next LLM call, or any um subsequent call by the user, or any uh, like if user wants to again follow up question, add a follow up question, then it will have a history, and based on a history and user question, it will decide, and LLM will give a output to the user. So this is the flow, actual flow. From here the flow will completes, and then uh, since we have called this call model, then we just print the output. Okay. Also, to get to know which function is selected by the user, we have printed that function name also, so that we get to know which function name is selected by the LLM to call to make this agentic workflow um, productive. So this is the way. And another, I have printed the prompt, which is once the respective agent functions is called, it will also print the information, this information, like this is prompt, actual prompt. It will print this, so that we get to know which function is called and what is written from that the function. So this is the code flow which I have I have demonstrated now. Let's have a demo now, so that how we can get to know how it is actually working. So let's call the main.py. So let's ask, I want to buy shoes. So now it is asking proactively. It requires quantity, address, and brand. So let's one Bata shoes. Bata shoes to be delivered on 201 Ravi apartment, Thane. Let's see how it works. So hmm, I have following items in Bata shoes. So it got this information that this is a select. This is the information. This is the product available. Formal leather shoes for Bata. That Bata brand, for Bata brand. This product ID. This is a price, and you are asked one quantity, and delivery address is this. Once you confirm this, and it is asking, do you want to confirm this order? So I'll just show is yes. Please proceed. So now your order for one Bata layer product ID at the price of 249 has been placed. It will be delivered to 201. So you can see the flow is perfectly going perfectly. It is first going to find the product, confirming from the user. Once the user confirms, it will it will call the place order function automatically. In place order function, it returning the assume that the API call is executed, and it is written that we have placed the order. So this is the for the shopping. Now I'll just ask to book a ticket. I want to book a ticket. So let's see. I can help you with that. From where to where do you want to book a ticket? And kindly provide the date and your name. So okay, uh, book a ticket from Thane to Pune. In the name Vikas on 31st December 2025. Let's see. Your train ticket to system. Okay, your train ticket to Thane to Pune 31st December for Vikas has been booked. So you can see it is confirming perfectly that these are the information provided and ticket is booked. Although I have not called any API, but ideally we do in a real-time scenario we call the API to actual do the transaction. I'm just giving a demonstration how the agents can work. I have created one orchestrator which can book a ticket, which can do a shopping for you, which can buy products for you, which can book a ticket for you. So these are two. There are many scenarios you can create these agents and do your daily task or any other use case scenario where the agentic workflow is suitable and safe to use. So this way you can do agentic workflow. Normally in low code platform, you will not get this information. These are raw detail. I have created this method, custom method to understand developer how the function calling is used to uh, build a agentic workflow, and these are the under the hood things which you will not get from anywhere. Normally I have created this function, custom function. It is not from any framework. I have created to demonstrate what the things are happening under the hood when you call, when you prompt to the agentic workflow, and it does lot of things. These checks, it does these checks and call the appropriate function internally. So I'm just the thing is I want to demonstrate how this agentic workflow under the hood it works, so so that you the developer can get to know how things works. So I hope you understand this concept and understand my code. I will also give this code sample in my blog post. I will add that into the my description of video. You can go to the description and you can get that information from that blog post. You will get all the source code from there, so that you can also try with this. You can try with other scenarios. Remove my agents. You can add your agents and try with this code, so that you can get to know how things are working. Okay. So till that time, just if you like this video, please press like, and if you are new to my YouTube channel, please subscribe to my channel and also press the bell icon, so that you can get to know all the information or all the new video updates time to time. Thank you for watching my video.